Greetings, Houdini Python students. This is the second portion of our exploration into the Who.Geometry class. Now in this section, we're going to explore attribute querying techniques as well as get a quick introduction on how to create geometry from the Who.Geometry class. Now the point attributes, primitribs, vertex attributes, and global attributes return tuples of Who.attrib values, whether they be from points, primitives, vertices, or globals. And to see what I'm talking about, we're going to create a brand new geometry object based on this red node here. And we're going to get this geometry information. Okay, so we do have a new red helmet. And to access each of these, I'm going to create a little for loop. So I'm going to go for ATR in red dot. We want to get point attributes. So point attribs. All right. Print ATTR. And then we see that there are 3 point attributes for this object: the point weight, the normals for every point, and the position information for every point. Now we could extend this to the primitives as well. And we're just going to extend that loop. Instead of point attribs, we are going to go primitribs. Thank you. And then we go and print this value. And we see that there are only one primitive value for the primitive attributive value, and that is the color information. Now there is a fairly large handful of attribute methods in the Who.Geometry class, and I would encourage the viewer to look through the documentation to give them all a try. Now this last method is save to file, and I am going to save this file, save to file, and the output for this determines whether determines the file format of our object. So in this case, I'm going to write it out to a geo object. Okay, so that outputted it to a red geo. We're going to come back to that a little bit later. Now for the rest of this session, we'll be looking at some very basic geometry creation methods. Now I created a blank Python SOP to demonstrate this code, and it's right here, and we'll go into creating the Python SOP at a much later lesson. So I'm going to right click onto this node and go all the way down to the bottom to where it says type properties and bring up the type properties. Now this brings up a little Python window that you're just going to have to accept that it is showing other contents, because I don't know if you can see this all. But if we wanted to create a brand new point, we would use the create point function. So point equals geo dot create point. Okay, now we see the geo is the geometry of the node, and the node equals the print working directory, or the PWD, which gives us the current node, which is that object. Now we hit apply, we see that we have a point right here, and we see that that point oscillates up and down with our animation. Now if we wanted to move that, we would just use the set position method to change our position. So point dot set position, and I'm going to give it a tuple of a vector of where to actually set this position to specifically. Now this is an absolute position. I'm going to hit apply, and we see that this now has moved down the value, so the value is much lower. So all I did was move it down in the value of y. Okay, where is it? Nice and high up there. Now for the rest of this session, I'm going to erase all of this information so we can go on to the create X method. Now the create X method, X refers to a polygon, a tetrahedron, or whatever graphic primitive you're dealing with. And in this case, we're going to be working on the polygon. So I'm going to say create polygon. So I'm going to go poly dot geo poly equals geo dot create polygon. All right, so it's going to return a poly information, and if I hit apply here, it disappears. Now everything disappears just because there's no polygonal information in here. We just have the blank poly object. So for that, we're going to have to create some points, and we're going to use a little for loop with some preordained positions in order to set that in place. So I'm going to create my points. The positions over there for pos equal all that. I'm going to say point equals geo dot create point, and then I'm going to set the position for every one of those points. So point dot set position, and for that we're going to use the pos value that we're iterating on, and then we're going to create a vertex for every one of those points. So poly dot set vertex to the point object that we just created. I'm going to hit apply, and we should see, uh-oh, what's wrong here? Okay, polygon has no set vertex. Okay, so so this should be add vertex. My bad. All right, we got that changed, and we should see a triangle there. Now, if we focus on the attributes, it can be done just the same. So if we want to add attributes, whether that be the point, vertex, or primitive, it's done the exact same way. So I'm going to say geo dot add attribute, and the inputs for add attribute are the attribute type plus its name and its initial value. And it looks something like this. Okay, so for this first situation, I want to add a new point attribute called bar, and I want to give it an initial value of 84. Now, we could do this again for the vertices. So I'm going to add vertex, and I'm going to call this foo, and give it a value of 69. And likewise, this can be done for primitives as well. So I'm going to create the type is prim. And I'm going to create a new one called a new attribute called primio. Don't ask me why. All right, I'm going to give this initial value of 76. I'm going to hit apply. And we have another error. Okay, has no value called attrib vertex. All right, attrib vertex, and it's a attrib type vertex. Okay, so I should change this to attrib type dot vertex, and I have a hunch that I made the same error right here. Type prim. I'm going to hit apply, and we can't see that directly, but if we go to the spreadsheet and look at the object for this, we notice that for this primitive, for each primitive, we have now a primitive attribute called primio. It has a value of 76. Each vertex now has an attribute called foo at a value of 69, and each point now has a attribute value of bar, which is 84. Now, if we wanted to set the initial values, we would just go ahead and use the set prim int attrib values, and that's a little bit of a handful. Like I said, please check the documentation for the actual information on how to use these, because what I'm trying to do is set the primitive integer attrib values, and I'm going to change it to 36. Now, the input for that is the primitive name, and then a tuple containing all the new values of the ones that we want. And if we check the primitive values here, we see that the value is now 36. Now, the last method I wanted to go to is the load from file information. And we're going to load in that file that we created earlier. And what that's going to do, it's going to replace the contents of the geometry with the data stored in the file. I'm going to go ahead and hit apply, and we should see that applied to the red sphere. Now, this last method wraps up our exploration into the who.geometry class, where we looked at the attributes and how to create geometry. This next session will focus on the who.python animation class. I'll see you in the next class.